Nonlinear functions, lesson 5.5. Okay. Linear. Let's remember what linear means. A line that is straight. And I always say all lines are straight, but some of you don't quite understand that part, so we're going to make sure that we know that it's when a line is straight. Linear functions have graphs that are straight lines because the rate of change between the two data points is constant. Remember that? The rate of change between any 2 points is constant. That is super important. We're going to go through that in a minute. Nonlinear functions are functions whose rate of change are not constant, and therefore their graphs are not straight lines. So if I look at this, clearly looking at a graph, it's easy to tell whether it's linear or not. If I look at this graph, is this linear? Okay, some of you are going to say yes. This part right here, oh, that was a line, but all of a sudden it went this direction. Okay, you can't, that doesn't go straight because this slope right here, or its rate of change, that's going to be negative. And this slope or rate of change is going to be positive. No way that those are a constant rate of change. Is the graph a straight line with a constant rate of change? No. The function is nonlinear because the graph is not a straight line. Here, right here. Again, this slope would be negative, this would be positive, but this is also making a U. Okay, this is making a U. It is not making a straight line. This is nonlinear because it does not have a constant rate of change. Okay. So, a square has the side lengths s. The area of the square is the function of the side. So, area is equal to side squared. So, we're going to plug these values in. If I was to plug in 1, what is 1 squared? 1. If I was to plug in 2, what is 2 squared? 4. If I was to plug in 3, 3 squared is 9. Plug in 4, it's 16. 5, it's 25. If I was to graph that, 1, 1, 2, 4. Oh, right there, you're probably thinking, yes, it's a line. 3, 9. Uh-oh. That's not going to make a line. 4, 16. Oh, that's definitely not going to make a line. And 5, 25. Okay. Do those points make a straight line? No. So this is nonlinear. And the hint is going to be, boys and girls, if this is an exponent other than 1, then it's not going to be a line. Okay? Exponents have to be 1. Okay, so if I look at this, a cube has the side length of s meters. The volume of the cube is represented here. V equals S cubed, sorry. The volume of the cube is the function. Here we have it. Is this a line? No, it is not a line. This is non-linear. It does not have a constant rate of change. This one. You can determine whether a function represented in a table is linear or nonlinear. To do so, you find the rate of change. Okay, so I'm going to look at this one right here. If I was to find the slope of the first 2 points, it would be -5 or -2 over 5. Here, it would be -2 over 5. Here, it would be -2 over 5. Okay, the rate is always -2 over 5, so the function is linear. Over here, if I did this, I would have 3 over 1, 5 over 1, and 7 over 1. The rates of change of 3 over 1, 5 over 1, and 7 over 1 are not the same, so the function is non-linear. So let's look at this. So if I'm looking at this right here, this goes up 175. This right here goes up 185. This right here, I have to use a calculator. Don't judge me. 13, 20 minus 5. This goes up 135. And then this goes up 100. And yes, your y values could go up by the same or by different numbers, but if you look here, all of these are going up by 1. These are all going up by 1. And since the numbers on this side go up by different numbers, that means the rate of change here is 175. The week from 2 to 3 is 185. So they are not the same rate of change, so it's not linear. So here, if I go from here to here, this is 5. No, it's not. This is 7. Sorry about that. This is 9. This is 9. Did I do that right? 9 plus 7 is 16. 16 plus 9 is 25. 25 plus 9. Nope. That's 11. I'm so glad. These are all going up by 1s. That means this is non-linear. Linear. Because it does not have a constant rate of change. Okay. In order for an equation to represent a linear function, the equation must be written in the form y equals mx plus b, where m represents the slope, or constant rate of change, and b represents the y-intercept or initial value. If an equation is a nonlinear function, it will have one or more of the following: powers other than 1 on the variable, so that goes back to the That goes back to these two that we did a minute ago. Okay. Oh, well, that could have been those right there. The square cube. Oh, no, these are roots. Sorry. So if it has a square root, or if it has a cubed root, the variable is in the denominator. So 1 over x. Okay? So these are all examples of nonlinear equations. So this right here, the equation y equals x over 3 can also be written like this. Is that equation in the form y equals mx plus b? Yes. So then that means, and some of you are asking, where's the b? Remember that this is a proportional relationship. So we don't write this part right here, but the y-intercept is 0. Okay, some people are like, oh no, that's not it. But again, this can be written as this right here. Is that in the form y equals mx plus b? Yes. It is in the form y equals mx plus b. So this makes this linear. Okay? Is this linear? Look at this. That has an exponent of 2. It cannot be written in this form. So this is nonlinear because it cannot be written in y equals mx plus b. Okay, then this one. Can it be written in y equals mx plus b? No, it can't. So this is non-linear because it cannot be written, in y equals mx plus b. The circumference of a circle is a function of the circle's radius. Similarly, the area of a circle is also a function of the circle's radius. So circumference is 2 pi r. Area is pi r squared. Okay. Then it says, which of the relationships is a linear function? Construct an argument. Okay. So, which one of these is a linear function? Well, if I look at this, this has an exponent of 2. Okay, it has a power. So that means the circumference is a linear function because it is in the form y equals mx plus b. Now some of you are like, no, it's not. It says c equals 2 pi r. Okay? This right here, pi is a number. This right here would be our m value. That would be our slope, or our constant rate of change. This would be the same thing as the y value. This would be the same thing as the x value. So yes, it is in the form y equals mx plus b. Okay. So the area of a square is a function of its perimeter. So the perimeter is equal to 4s. Which of these relationships is a linear function? Well, this right here has an exponent of 2. So that means that the perimeter is linear. Okay, the p-value is just like the y. The 4 is the rate of change or the slope. Oops, I did not mean to put another y. And the s is just like the x value.